I'd like to introduce myself. I'm Megan Garvin, Director of Research for the Maryland Center for Computing Education. And today I'd like to introduce Tom Newmark. He's been involved with education for over 20 years. He has coached First Lego League robotics team for about 4 years, even qualified for state competition. He has a bachelor's degree in computer science from West Virginia Wesleyan, and a master's degree in computer science from Johns Hopkins University. He's currently working as a software engineer at Microsoft, and he's the founding president of the Frederick Classical Charter School. So, hand it over to you, Tom. Thank you for being with us.
Oh, thanks for the nice intro, and thanks to everyone for being here. Yeah, today I'm going to talk a little bit about the AI careers, the theme of which is it takes a team. So a common question I get from folks that aren't in the industry is, well, if someone wanted to get into your industry, you're managing a group of people that do AI stuff. What would that look like? What are the skills they would need? The training, education, and then give me an idea of the salaries, the jobs and salaries, what's available. So first I'll just start with something that I think most folks are very well aware of. All the industries, which is basically every industry, is impacted by the AI revolution. So we're seeing more and more jobs across more and more industries that have some kind of AI connection. Everything from construction, you can actually, rent robots that will build a small house for you using AI. There's business intelligence, figuring out what folks are, other competitors are interested in. Retail, we actually have a product called Connected Store. I work for Microsoft, and it will detect, you put a camera on like a cereal end cap, and it'll detect when the cereal is missing, and it'll send a signal to folks in the back to go replenish the boxes of cereal, so that when you don't have enough Cheerios on the aisle, you get more Cheerios. Healthcare, predicting patient outcomes. Who in a nursing home is most likely to have a fall or another health incident, and can you prevent that from happening? Transportation, we've all seen autonomous cars. Education, the adaptive testing, where you get an easy question and you get a harder and a harder. All these are different applications of AI, both systems that are like traditional AI and rule-based systems that will try to predict and help humans do something a little better. So really across the bottom line is across the spectrum, there's a lot of different AI types of things that are really revolutionizing a lot of industries, or at least have the potential to revolutionize. So how much impact is there? I mean, a lot of the jobs in the future are going to be related, right? So the big thing we have in the industry is a pretty significant shortage. If you can spell AI, which is not too hard, and you have some concept of it, you may find that employers are actually more interested in you, even if you don't have a super formal background in it. If you have some passing knowledge as a computer science person, engineer, physicist, there are folks that are interested in hiring you and then training you and getting you to a higher level because of the supply and demand curve right now is really favoring candidates. So it's kind of like Java and web development was in the 90s. It's kind of how AI is now. If you're willing to learn and you have some semblance of a background, there are a lot of folks that are really interested in hiring you. Some of the specialties so within the sort of the broad category of AI, there's automating your business, right? So taking humans out of the loop can make business more efficient. You can have agents, for instance, electronic agents that go to, let's say you're having to purchase lumber. You can have intelligent agents that will actually go out and scan the web and go to markets for lumber and try to find the cheapest prices and negotiate on your behalf. So rather than having a human do that work, you can actually have an agent that works on your behalf, a digital agent that basically is doing your ordering for you within some parameters that you set. There's data and analytics. So basically, if you have data, what drives artificial intelligence is what we call big data. So since we've been using the internet, companies like Microsoft, Google, Yahoo, etc., have collected a lot of information about our preferences, things we like to buy, and they've stored it in the cloud, which is really just football size or greater warehouses full of 10, 20, 30, 40,000 computers that are storing all this information about us. And with all that information, we can find patterns. And so that's why sometimes you'll go to a website and you'll be looking for a can of tennis balls. And then you go to some other website and you start to see ads for tennis rackets and other tennis related things, right? We've all had this experience. And that's driven by the fact that there's all this data that is stored about us in the cloud. And we're able to extract patterns and figure out what people are interested in buying and then use it to customize the ads. All right. So some data, some job titles that are available in the industry: data scientist, data science, AI engineer, ML, chatbot. You can specifically be an expert in creating chatbots. NLP, we heard about earlier. So that's natural language processing. It's taking English and German and French and all these different languages and trying to figure out what it's saying. What is the meaning behind those words? To a computer, each word can actually be assigned a number, right? So the word "the" maybe is assigned the number 2028, and the word volleyball is maybe assigned the value 528,003 or something like that. By assigning, each word in every language a number, and then figuring out which numbers are most commonly seen next to each other. So we talked earlier about the engrams exercise where you're doing like cheesecake and cat food and trying to, figure out the middle word. NLP is basically using that technique to figure out the meaning of words. So if you talk about cat food and dog food, the natural language processing engineer might figure out that both of those things are types of pets. So the word cat and the word dog is a type of pet. So by association, by figuring out which words are commonly next to each other in sentences, you can do a lot of work to figure out what types of articles people are interested in, what types of videos people are interested in, all using that technology. Some that folks don't know about as commonly are a technology ethicist. So it's someone that looks at using AI. How would you do that properly? So for instance, we mentioned earlier in the main discussion about, well, what if we have an algorithm that's biased and was, looking at folks that were getting approved for a loan, and your data was all biased towards folks that were in a minority group or a particular geographic location. A technology ethicist can actually examine those issues and figure out ways to get more representative data so that the final outcome is a loan application that's really fair using AI. So data wrangler is actually my favorite title. So a lot of the data, most of the AI work is actually not in the training of the AI. That takes a lot of computing time, but it's actually gathering the data. So for instance, if you wanted to identify cats and dog pictures on the internet, a data wrangler would have to go and get, tens of millions of pictures of cats and dogs and label them, like this one's a cat, this one's a dog, this one's another dog, right? So a lot of the work in AI, interestingly enough, is not technical in the sense of doing the AI math, but it's just getting enough data to actually make the AI math work. All right, so those are a few of the titles. So for data science is considered a subset of AI, which it's really analyzing the data, and it involves three main things. One is just a computer science major, typical skills that you would have with that programming, right? And then mathematicians and statisticians, and then the subject matter experts. Like if you're doing AI for healthcare, you would need someone that actually understood healthcare. If you were doing AI that was related to figuring out where oil is in the ground for the oil and gas industry, you would need someone that has that knowledge. And so the reason why a lot of AI is done is teams, is no one is the unicorn that actually is the oil and gas geophysics expert and the math and statistics expert and is a computer science degree. I mean, maybe there's like three people in the industry that would have that combination of knowledge. So it's done in teams, right? And you can kind of see the overlap. So like if you're a computer scientist that understood healthcare, you might be able to write healthcare software, right? But if you're a computer scientist that has lots of math and stats in their background, you could do the machine learning. And then traditional research background would be, statisticians who are dealing with like biostatistics, combining healthcare and math and statistics. So the important takeaway for your students, right, is that they don't have to know it all. No one really does. Very few people really do. They can be a pure math person or someone that just understands healthcare or that understands computer science and combine those skills in some interesting ways. The other thing that I always like to tell folks is that you don't need to be super technical. I mean, obviously, if you're going to apply for a job at like a place like Microsoft or Facebook or Google, you get a technical interview and we expect you to know technical things because we typically only hire folks into those roles that can do those things. But you can be someone who is hired into a role at those companies that is more business oriented, more of the subject matter expertise that has basic knowledge of AI, but doesn't actually write the AI and uses some of the tools. So this is an example here of a product from Amazon called SageMaker. And someone has to do this first step here of building and managing data sets. So if we were doing, let's say we're trying to predict, detect if a bone was broken in an x-ray, right? So you would collect lots and lots of pictures of x-rays. In a very special format that is an X-ray format that's a high-res graphic format. And you would label them like this part of the image has the broken bone, or no, there's no broken bone in this. And you have to do it for different body parts, right? A hand fracture, an arm fracture, a foot fracture, an ankle fracture. You have to categorize those and arrange that. And that's not really a super technical skill, and it's really putting things into folders. But there are people that need to do that and to manage the groups of people that are doing that. And then you can run SageMaker on it, or like Microsoft has an Auto ML product and different companies have different products that will then run these pre-trained models that know how to identify features in images and then try to produce a result. And then you can tweak the results of that without having a ton of technical knowledge. You only have to have basic concepts of AI, and the software will let you tune it. Obviously, if you want to get to a certain level of expertise in it to really make your AI predictions work well. At some level, you do have to have that technical knowledge, but to get sort of basic common things working, you can get pretty close and not have tons and tons of knowledge of the inner workings of AI. So here's a scenario I wanted to have you guys think about. So let's pretend to put all this together, like you wanted to make your own cloud. So you want it to be the next Amazon or Google or Microsoft and make your own, you got $1 billion investment, which is about what it takes for a single data center. And they run typically about $1 billion each. So you wanted to do that, and you wanted to provide the ability to analyze video streams using AI and ML that was formed on the edge. So let's say that you had a hospital scenario, and let's say you were trying to predict whether people were about to fall out of the bed. It's a common thing, especially in elderly populations, and it causes a lot of problems and lawsuits. So you wanted to get to the point where you could have a video on folks with their consent, of course, that was for the protection. There's just watching them in their hospital bed trying to predict if they were going to fall out. They're getting too close to the edge. So we have these small servers located in the hospital that will do all the processing there, so that the video feed is never shared with the larger cloud, right? With the Microsoft big building or the Google big building that's typically in Northern Virginia in our area. And so you have to put bounding blocks around people who are not wearing masks, or in our case, let's say we're changing the scenario here to fall out of bed at 24 frames per second, and you have to train these models, right? And then you have an additional challenge is the solution has to be carbon neutral or negative, and it has to be deployed through an easy to use interface within 5 minutes. You get this edge device, it goes to your hospital, you got to go somewhere and just hit a couple buttons and make it work. And then the people are going to pay, the hospital is going to pay you to have these devices, and they pay every time they do an inference. They're gonna be charged, a quarter of a cent or something like that. So what people and skills do you guys think would be needed to do this type of thing? Take a guess. You wanna?
I'd say people who are fairly creative, dedicated, interested and passionate about the topics.
Definitely, I mean, having the passion. Think about like, so we're charging people money, right? So maybe there's a person that needs to manage the money, right? They're building AI models. We're building data centers. So definitely, we need people who are passionate about. But what types of skills, I guess? So they have the passion. That's great. Let's assume that. But what kind of skills do they?
So then I'd say detail oriented, and ability to work independently as well too. So like, you know, being given a little bit of information but able to make inferences.
Sure. And then what, those are personal qualities, absolutely. And then I'm thinking more of like specific technical abilities, like job roles. Like, what do you think you would need? Like, someone has to do the AI stuff, right? So, one example would be like, you have to know artificial intelligence. So you need someone that is like a machine learning engineer or an AI engineer. They have to know that. Any other thoughts on things? Because those personal qualities are absolutely correct. Don't get me wrong, but I'm thinking more of the technical or even non-technical skills that they might need to put this together. The one big clue is they are constructing buildings, right? So you need construction people, folks that can do that. All right, well, if we don't have any more guesses, I'll show you the next slide. Any more guesses before I go? All right, so here's a couple. So these data centers are huge. They're the size of a football field and sometimes multiple football fields. So you need to, be able to build data centers. So you need construction folks. You actually have to navigate international law because there are different laws that apply to this in terms of privacy of patients. When you're doing these video streams, what laws apply to you? How long do you get to keep that video? You need the video for training purposes. So you're going to keep it for 10 years. Do people have a right to not have their videos be used for your training? So all that kind of stuff has to happen. Building the actual edge devices and servers for data centers. So you have to have hardware engineers. And then here's an interesting one. The building, training, and optimizing AI models for less energy consumption is a real issue. I said down here at the bottom, training a large deep learning model produces 626,000 pounds of CO2. It's about as much as 5 cars would produce in their lifetime. So reducing that would have a big impact because people are training models repeatedly. Like at Microsoft, we have folks that will go and train a model for 2-3 weeks or more, and that's producing a lot of CO2. Once it's produced, it doesn't use as much. It doesn't produce as much CO2, but actually getting to the point where the model, the predictor, that's what we call an AI, they call it the model, the thing that like takes an image and says, oh, this is a cat or this is a dog. Training that can take a long time and uses lots of energy. And then after you've done, so as part of building a model, you're going to ensure that the results are correct, right, using ethical AI. So usually you have an ethicist, sometimes even philosophers. Like Google actually hired a philosopher to not only handle the AI stuff, but also just help employees as a benefit with any philosophical issues they had about either their work or even their personal life. I thought it was kind of funny that Google would hire. They have a resident philosopher that like roams the halls and talks to people. It's kind of interesting. And then once you produce this 626,000 pounds of CO2. Can you recover that? Can you purchase carbon offsets? So carbon offsets, right, are things that there are companies that will actually go and plant trees and do reclaiming carbon in various ways through technology. And so I know, like in our company, Microsoft has actually paid folks to reduce carbon in the environment to try to offset some of the work that we've done in AI and other cloud computing, and other companies have as well. But then there's also selling the solution and managing the billing and financials, which folks don't think. If you're charging folks for every inference and it's a quarter of a penny or a tenth of a penny per image that you predict masking or unmasking, or you predict the bone broken or whatever it is, you're charging folks for that. So you have to give them a consolidated bill. So you actually need a lot of accountants and finance people to predict, is the amount of inferences that folks are using, is that actually paying our electricity bills, is that paying our bill for the servers, is that paying the bill for the folks that do the AI? Are they actually making money? And then sell the solution, which I said right before that one. So it's interesting. So at Microsoft, a lot of our staff, I think it's like 45%. Like most of our job roles are actually sales. People don't realize that. They think it's a bunch of engineers. But we have a substantial portion of our, it's most, I believe, last time I checked, most of our staff is actually in some kind of sales role. Because the only way you do well as a company, if you understand what your company, what your customer wants. And so you have to develop those close relationships. So I'm sure it's not just true of my company, it's also true of many companies. But you have to know what your customers want. And the best way to do that is to have salespeople go and meet with them and ask what's the next thing they want. Oh, sorry, I have a question. So then in terms of a salary, so the national average salary is 122,000. In our area, it's actually probably substantially more. And this is more of like a starting salary. So typical folks, if you go to like a Google or Amazon or Microsoft, fresh out of school, typical folks are making, with computer science degree over 100,000 in their first year, and that's not including stock and signing bonus and all that. That's just the salary is well over 100,000 at any of the large, Facebook, Google, Amazon, Microsoft companies. That's a reasonable expectation for everyone. There's no one that my group has hired in the last several years that makes less than 100,000, and these are folks that are 21 years of age, right? So gives you an idea, and that's obviously as you get more experience and so on, the salaries will go up. So there's such, again, the job supply demand curve on this is really favorable to people who have these skills. Fresh out of school, it's pretty hefty compensation package. All right, here. Let's see. So what's in Maryland? So this is a nice link. If you look behind, they can actually go to like the job postings in Maryland, specifically in Maryland, for Maryland focus. So that's something kids can look at if they're interested in learning more about this topic. All right, so I think we have like maybe 10 minutes left. I wanted to kind of field any questions you had. Can definitely give you like a day in the life of a software engineering manager / AI person, because I deal with that day in, day out. And let me go and stop the share here. All right, do you guys have any questions about anything I covered or topics of conversation you wanted to get over? Surely you guys have questions.
How would you recommend students get started if they're interested in this field?
Sure. So if they want to like be a technical role, right? They definitely need to take math. You need to take calculus by the time you graduate. If you don't do that, you can make up for it in college, but it's hard. So it's better if you get at least calculus 1 through like the A course, like in the AP. Like at least do that. And stats, I would actually take AP statistics as well. That is sort of a area that isn't realized as much. So basically, if you take AP Calc, right, like the easiest course, and you take AP statistics, you actually have most of the math you need to do AI just coming out of high school. The only other thing that you will do in college is you'll take linear algebra, where you do a lot of matrix math, and you don't even need all of it. You just need, it's almost like the first half of the course is the math that you actually would use. And that gives you enough to understand neural networks really well. So neural networks basically involve a little bit of linear algebra, so dealing with large rows and columns of numbers, long lists of numbers and doing calculations on them. You have to understand the concept of a derivative and an integral, right? The two basic concepts in calculus. And then you need some programming knowledge. So I would recommend taking like the AP computer science course, not the, I'm forgetting the name of them, but the one that actually is the Java course is the one that you want to actually do programming. And I will say that most of the programming is done in Python, is the language of artificial intelligence. Machine learning, there are a lot of really good libraries there. Most people don't do it in Java, but I would recommend you learn Java and Python as your languages. Java is a more general language and it's widely sought after. And a lot of times you'll be needing to use Java technologies to present like your visualizations and things. And then Python is what you would actually produce the models in and actually like data wrangle for that term in Python. So yeah, those would be the things that I would study. And then, you probably will end up having some area of interest. And I really encourage folks to use this area of interest to explore data science. So I have a friend that loves baseball statistics, right? And that's a great thing to explore. He and I actually worked on a little project to predict who would get into the Hall of Fame based on their stats. And so stuff like that, if you have a cool application that's like, I like music and I'd like to like predict which records, I would, call them so dated, record CDs that folks would like based on their preferences. Like if you have an area of interest that gives you some practical application and then makes you want to learn the AI, I find that's often, very motivating to students. So something that they like, whether it's sports or music or computer graphics, it doesn't really matter what, but there's always a tie into AI somehow. So if you can kind of figure out like, oh, I really like chatbots, I'm fascinated with that. Or I really like natural language processing. Isn't it cool? We can like talk to a computer. Usually folks have, I think you mentioned before, some kind of passion about something, and then they learn, that motivates them to learn all the math and the AI and programming stuff. Like, I want to do this cool thing. I want to be able to talk to my computer and have it understand me. And then they get fascinated with it, and that will motivate you to like learn the math and the other stuff to be actually able to do that stuff. So yeah, great question. Other questions? All right, we have 9 minutes left, so I'm sure there's some more questions. You can talk about like
go ahead.
Sorry, I had a question. I'm looking at the shot up that you put up about what other roles are available, and I'm thinking, what about students who calculus is just not going to be their strength? I mean, it looks like there's construction, international law, there's the engineering of building the edge systems, there's a whole bunch of other areas around building these AI data centers. How do I go about, introducing where do we introduce those concepts?
Sure. So we've done a wonderful set of presentations on like the ethics route, which is very popular. So I would say introducing those concepts, we have the slides Diane can share out on like posing AI ethics problems. So one, we call it an AI ethics problem, but really it's an ethics problem. So imagine you have a autonomous car, just to give you an example of this, you guys may have heard this one before. And it's driving along and it has to make a choice. It's going to hit one of two cars, right? So it's going to either hit a more expensive car with 2 people in it, or it's going to hit a less expensive car with 3 people in it, right? So what should it choose, right? So dilemmas like that, introducing that concept of what should the computer do is kind of in the philosophical and ethical realm. So I would say folks that want to, take like AP courses that are related to the humanities would be a good match for something like that. Thinking about philosophical ideas and what is the right thing to do in various situations is good. Any course on like logic would go along with that. So it's not technical per se, but it's more syllogisms and fallacies, logical fallacies and things like that. Those would all be good things if you were interested in like becoming an AI ethicist. And then you would probably go and major in philosophy, but you would need to take some computer science courses, at least like an intro to programming course, because if you don't get the very basics of it, it's really hard to reason about it, right? So you have to have some level, even if you're not super technical, like doing the day of code is helpful, right? To develop at least the conceptual understanding of what does it mean to program a computer. And once you understand the basics of it, you don't have to know all the nitty gritties of all the languages and operating systems, but just knowing like, okay, programming is basically a logical series of steps and rules. I can get how I would deal with that philosophically. And then construction, obviously, that part, if you have an interest in that, all the standard construction skills are great, and specifically understanding like the electrical stuff. How do you most efficiently get power to these racks and racks and racks of servers? It's thinking about the traditional things an electrician would be trained in, but it's very specific to data centers. So like these machines, like if the power goes off to the entire data center, how do you recover, right? So what they actually do, no joke, they run the data center. Some of them use flywheel technology. So the electricity comes in and it makes this huge flywheel. It's like it's multiple stories high. It's literally a wheel. And that is generating enough electricity to power the data center. If the data center gets its power cut, the flywheel continues to spin for a period of time, long enough so the generators can kick on to actually continue to spin that flywheel. So like stuff like that, there's like really neat problems that folks that are going in the construction industry would not typically deal with anywhere else. And that can be, getting folks inside the data center to look at that. There are lots of videos that Google and other folks have put out there about the innards of a data center and what it actually looks like. There are data centers that have battery rooms that literally have just stacks and stacks of batteries. They have to be cared. They're high-powered batteries, but they run off chemicals, and they have to be very careful about how they deal with those, because if they ever tip over, it's going to cause a chemical reaction. But if they work well, it keeps the data center up in the event of a power supply issue. So anyway, stuff like that, I would introduce folks to those topics to start thinking about, because it is fascinating, even if you don't intend to go into construction. It's something as simple as, oh, well, all this electronic equipment's in the data center, so I have to put a lightning rod on the roof, because what happens if lightning hits the data center? It would kill it. So just neat, if you can, and I can help with this. You guys can email if you don't have if you want some more info about this. Just figuring out the simple logistics of a building. It's amazing what goes into these buildings to be able to do that. And then law, again, that's definitely the humanities realm is that. Teaching the basics of hardware construction, like getting folks to work with a breadboard, when we used to, hooking up just simple lights and sensors and making sounds work. Things like that could lend itself to getting kids interested in like the hardware path of actually building the computers. So that's kind of a cool thing. Raspberry Pi kits are great for that, as well as just traditional breadboards that are really simple. You connect it to like a 9-volt battery and you turn some lights on and you see what works. So I don't know if that answered, but that's a few ideas of things I would look at to kind of interest kids in some of the other areas as well. Other questions? Sorry, that was a long answer to that very good question. All right, well, I can talk a little bit about a day in the life of AI, if that helps. So like for my team, we are actually doing that scenario that I described. We are actually building out these edge devices, and it's a team of teams, right? So there's a team that does the AI stuff to detect objects. So for instance, if you were flying a drone around trying to detect a lost hiker, you might look for like cups and camping gear and things like that might indicate that someone has fallen down some area that's really hard to get to and they drop their stuff, right? So you actually fly drones around and use object detection, it's called, to detect objects like different, pocket knives, flashlights, all these things that you might find with a lost hiker. And so there's a team that actually puts that AI stuff together for us, and then we actually package it and put it onto these edge devices, which are like battery operated servers that will run for 4 hours. And you can actually fly a drone, connect it up to this server that runs literally in your backpack on a battery, and will do the AI detection there. And so you can get alerts sent over a radio network or a satellite network back to headquarters to say, look, here's what we found in this location. So our team is actually producing that kind of software to help with search and rescue teams. And it involves we have program management. So people that don't do any coding at all, they just manage the schedule. They manage like, what do we need to, the logistics, right? Of like, what do we need to do this? How much power do we need for this machine? They're not dealing with the innards of the hardware. They just deal with the specifications, and they figure out like, what kind of batteries do we need to order to run this machine off of, because it's battery operated. What is the schedule for the software to be developed? What are the major tasks and that for us to go from having nothing to having a working solution? What are the major milestones and tasks, right? So there's a lot of like project management stuff that folks can get into as well. And for that, folks would probably look at like business majors, right, to do. And again, taking maybe if not a minor in computer science, at least a couple of computer science courses to have done at least a little bit of programming, because it's hard to manage programmers if you haven't ever done at least basics of it. So that would be a way that folks could get into that too. But yeah, day in the life is basically, we have a lot of folks, including non-technical folks, that are all working together to make these solutions work. And then we have our core engineers that are actually, writing the code to put the website together. We have a guy that actually became a certified drone pilot, so that he could do this for us for the searcher. He's a programmer, but he actually went and got his license to be a commercial a drone pilot, and that's a career opportunity too, to be able to do that. A lot of folks don't realize, but actually running the hardware is a job as well. All right, any last questions? I think we're down to the last few seconds here.
Thank you so much, Tom. Thank you for joining us. If anyone else has more questions, we can always follow up with Tom later.